This question is from GATE 2014, Mechanical Engineering paper set 2, question number 37. Maximum fluctuation of kinetic energy in an engine has been calculated to be 2600 joules. Assuming that the engine runs at an average speed of 200 rpm, the polar mass moment of inertia in kg meter square of a flywheel to keep the speed fluctuation within plus or minus 0.5% of the average speed is dash. Let's write the given things first. So the maximum fluctuation of kinetic energy, we can write it as delta E, is given as 2600 joule. Engine is running at an average speed. So N, average speed, is 200 rpm. We need to find out the polar mass moment of inertia I, and we need to keep the speed fluctuation within plus or minus 0.5%. That means we'll write speed fluctuation delta omega as plus or minus 0.5%. It is given. Let's find out I. Now we know that fluctuation of speed delta E for a flywheel is given as I omega square into Cs, where Cs is the coefficient of speed fluctuation, which can be found out as Cs will be equal to omega max minus omega minimum divided by omega, which is the average speed. Now this value is given in terms of percentage. So delta omega actually is 0.5% of omega of the average speed. So we can find this out as plus or minus 0.5% of omega upon omega. Cs will be therefore equal to plus 0.5% is nothing but 0.005 minus 0.005. This gives us value of Cs as 0.01. Omega is known, Cs we have found out, delta E is known, we can find out I now. So I will be equal to delta E, that is 2600 joule, divided by omega square. Omega directly is not given, but we can find out omega using N. If N is 200 rpm, omega will be 2 pi N by 60, which is 2 pi into 200 by 60. Square of this into Cs is 0.01. This, when calculated in digital calculator, gives us 592.73. This is mass moment of inertia, it is kg meter square. Let's go back and fill in the answer. So the polar mass moment of inertia is 592.73 kg meter square. To further learn about flywheel analysis, you can refer to the NPTEL video Module 6 Lecture 2 Flywheel Analysis from the course Lecture Series on Dynamics of Machines. This course is by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering of IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.